Standard 4 audio file types. Number 1, a file type that is lossy and has been used for digital devices since the 1990s. So that means that it actually loses data. It loses some quality to compress this audio file from like an original file that has a lot more data down to something smaller so that it can be, sent over the internet faster, so that you can put more of them on your hard drive or your phone or whatever. So it's compressed. It's a lossy file. And you can guess what that is. That's the MP3. They're kind of starting to go away, but they have been around since the 90s as like the de facto standard. Number 2, for consumers that is. Number 2, the file types that are lossless and are used for CDs, etc., are .wav, .wav, and AIFF. Those are some of the standards. And number 3 says the file type that is lossless and half the size of a .wav or .AIFF, some do say AIF, I never have, is an FLAC. And that is new. I'm going to say that's really only been coming on in the last 2 or 3 years. And then here we talk about what it means to have a sample rate. That's going to be this next one here, sample rates, and what digital files look like. So if this is a waveform, it always goes up and down, right?
So that you can see the shapes of the waveforms clearly.
But this is just a very simple tone. So a low sample rate means that I take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I take 11 snapshots to try to recreate it. But what I really get is this kind of a look. Okay? So a low sample rate may not give me all the characteristic of that sine wave. If you have a low enough sample rate, it'll actually sound more like it's a buzz. I can't do that with my mouth, but I'll give it a shot. Instead of a whoo, it might be how's that? Sounds like a chicken dying. A higher sample rate takes more snapshots. I'm not going to count that many, but that's probably closer to 30, okay? So the more snapshots you can take, and it's in the thousands, right, the more accurate you will be to the original signal. So this is what they call an analog signal, but you're making it digital. You're turning it into zeros and ones. 44.1 thousand, roughly 44,000 snapshots per second, and 48,000, and that's kilohertz. So kilo is always 4,000 if you're in the metric system, right? 44,000, 48,000 are examples of common sample rates. Okay, now we talk about bit depth, and this plays into your MP3s quite a bit. So with bit depth, well, let's go ahead and answer this first. 8, 16, and 24 are examples of common bit depths. So the bit depth is showing you the amplitude, how often it's basically taking a snapshot, how deep it goes, and then across time is the sample rate. So it says if you multiply the bit depth and the sampling rate, you get the bit rate. So if you've seen these numbers, 128, 192, 256, you have. And you just know the higher the number, the better. But now we're talking about the bit rate. So on your MP3s, 128 is fine for my voice. But once you have a lot of data going on, a lot of frequencies, music that has, strings and violins and flutes and a soprano singing, and then you have a bass singing, you have bass guitar, you have a cymbal crash. There's a lot of data in a cymbal crash. It won't sound very good on 128, but it will at 256 kilobytes per second. All right, now you know why you want a higher number. And now we actually talk about that on the chart in terms of the actual amount of data. So a WAV or an AIFF file at 16-bit, which is always what it is, by the way. It's always 16-bit, 44.1, for most CDs, 48 for some things like video. It's actually 96 kilohertz sampling rate for Blu-ray, interestingly enough, high definition Blu-ray. So watching audio on your home theater system is typically better than putting an audio CD, even though it's audio CD, in your car. You're saying, well, wait a minute, that's an audio CD. It is specifically used for audio, where a Blu-ray is for a movie, for video. Well, the CD came out in right around 1985, I'm going to say, and they had that standard. It'd be fun to look up, see how close Walker is to being right. Right around 1985, CDs started selling, and they had the standard of 16-bit 44.1 kilohertz. And we've just had to live with that ever since. Blu-rays come along, high definition video comes along some 15 to 20 years later, and they can say, let's increase it. So they have 24 on bit depth, and they have 96 kilohertz on the sample rate. So it's a much better sound, frankly, on your home theater system. All right, well, anyway, as far as the amount of data, if you recorded at 16-bit 44.1 kilohertz, is this for 60 seconds? For 60 seconds, you would have right around 11, about 10.5 to 11 megabytes of data that you would actually have to store, whether you write it to a CD or you put it on a thumb drive or you actually just have it filling up your phone. So if you have a 100 megabyte hard drive on your phone, how many songs can you get at this full data rate of 1644.1? You might only get 3 songs. But now you come to the MP3s. If you're at 320 kilobytes or 256 or 128, you're down below 3 megabytes. You might have an entire song that is only like 2 megabytes because it's compressed down to an MP3. Still sounds really good, by the way, but it's not the same quality as a WAV or an AIFF. So that shows you the actual amount of data and why it's been compressed. Number 7, like I said, if a song is 35 megabytes as a .wav and 3 megabytes as a .mp3, that's when we're talking about a difference in file size.